and this is operations with complex numbers. So by the end of this module, you'll be able to simplify radicals that include imaginary numbers and perform operations with complex numbers. Complex numbers are just numbers with imaginary numbers, with i's. So you have to remember I is really the square root of -1. And therefore, we're going to take the I squared and we're going to say it's the square root of -1 squared. And that is going to end up being -1. The reason for that is the square and the square root, they cancel each other out. So what is left is that -1. And that is a property that we're going to use later on. So we have done this a few times with quadratic equation. All we're going to do is simplify this radical. So simplify means I'm going to break out the -48. I'm going to look at it as -1 times 48. Because there's a negative in there, I comes out, and I'm going to look at square root of 48. So I break down square root of 48. There's a couple ways you can do it. You can look at it and say 48 is what two numbers multiplied together. So you can do 4 times 12. And then I can break that number down again. I carry down the 4, and 12 is really 4 times 3. You notice I create two 4's, which multiply to 16, and then I can find the square root of 16, which is 4. The 3 stays in the square root. Now, I also have to remember that the I is still out in front. So this I I've been ignoring for a while, but it's been out in front the entire time. So my final answer is 4I square roots of 3. That's how I do it. Other way is example B, I can immediately jump to a perfect square. So I can say that -1 times 9 times 7. Okay, so I can break up that 63 right away. Now -1 becomes the I. 9, I can find the square root of that, which is 3. And the 7 doesn't have a perfect square, so I'm going to leave that as 7. That is my final answer, 3I square roots of 7. The next thing is getting into operations with i's. So the first thing I notice it's multiplication. So -3 times 4 is -12. I times I you treat as like x times x. It becomes I squared. You have to remember, okay, that special note that we had where I squared equals -1. So every time I see I squared, I'm going to replace that in. So it becomes -12 times -1, which becomes 12. And that's my final result. For example B on this, I have two square roots. So the first step is take out the i's or the negatives, okay? So both of these have negatives in there. So I'm going to put i's out in front of both of them, okay? So I square roots of 3 times I square roots of 15. The second step in this is I'm going to combine the two square roots. Okay. So it becomes the square root, okay, of 3 times 15. Now I can also combine the two i's out in front. I times I is I squared. We'll get back to that later. Now, inside that square root, I can break down that 15 and carry down the 3 into 3 times 5, which is what I wanted because now I have a pair of 3's. Okay, I carry down that I squared in front. So I have the pair of 3's. So 3 times 3 is 9, and I can take the square root of 9, which is 3. Now what you have to remember also is that I squared, again, is -1. So I'm going to carry that down, okay? And it's going to be -1 times that 3. So it's -3 square roots of 5. That is my final result. So I always have to remember to break down my square root. And make sure I'm combining all my i's. Okay. The next example is a thing that we've seen before when we're solving with square roots. So we just take the normal equation when we solve it by subtracting 5. Now x squared equals -5, so I'm going to take the square root of both sides. Whenever I'm solving for x, that's when I have the plus or minus. And if I have a negative in the square root, I comes out, square root of 5 stays in. That is my final result. On the back side of this paper is all about operations of complex numbers. So operations is really just addition, subtraction, and multiplication. That's all it is. And all it is combining like terms. Okay? So we have done this with variables before. So I'm adding two things together. So I'm going to combine like terms. So the 6 and the 4 are like terms. So 6 plus 4 is 10. And I have 1i minus 5i, which is -4i. And I'm done. In example 2, I'm subtracting them. What you have to remember is that subtraction goes to both of those. So the new thing becomes 8 plus 3i minus 6 plus 2i. The two negatives become the positive. And now I'm combining like terms. 8 minus 6 is 2. 3i plus 2i is 5i. And I'm done. The hardest example is when I'm multiplying. Now, there are two methods whenever I'm multiplying these things. And we have done both methods when we're dealing with quadratics. There's the box method, which most people are comfortable with. So I would put 2 minus 5i on the top, -4 plus 2i on the side, and multiply. So -4 times 2, -8. -4 times -5i, 20i. Plus 4i there. And now I have -10i squared. Remember the I times the I squared. I combine what I can. Okay, so I add all those in the middle of the box. So -8. I'm going to combine that middle piece plus 24i minus 10i squared. What we have to remember, again, is that whenever you see I squared, it is equal to -1. So I'm going to plug that in every time I see an I squared. And I'm going to multiply that -10 or -10 times that -1. And I'm going to make that a +10. And now I can combine the -8 and the 10 into 2 plus 24i. The other method that and that's my answer. The other method that I can do is called the FOIL method. So where I am just distributing and I'm not using the box. It comes out to be the same answer. It's just another way of writing it. So I do 2 times -4 and I get -8. I then do 2 times 2i, which is plus 4i. Now I take the -5i times -4 and I get plus 20i. -5 times positive 2i is that -10i squared again. Now I'm just combining in the middle. So that's where I get my 24i. I again replace that I squared with a -1. And I'm back to where the box method got me. I end up with the same answer, it's just written a little differently. So the rest of the problems on this sheet on both sides are practice of these skills. Please come in with any questions next class. Thank you.